Hey, hello guys, welcome back to PyAI Hub. So today we are starting our new series, which is advanced version. So here we are gonna work with pandas. Also, we are adding NumPy to it because it has some numerical values. So for that, we really need that. Okay. So in this advanced series, we are no longer working with clean, perfect tutorial datasets. We are working with messy, realistic, real-world data, the kind of data you will usually see in companies, Kaggle projects, and real analytics jobs. Okay. So that's what that's how the data in real companies. Okay, so in real projects, most of your time is not spent on machine learning or fancy charts, but fixing messy column names, handling hidden missing values, cleaning test fields, or finding the correct way to fix the broken dates, and converting bad numerical data, or making the dataset reliable and analysis ready. So in this video, I'll show you how professional analysts clean and normalize data so it becomes trustworthy and usable. So this is one of the most important skill analysts need while handling the real world data sets. Okay. So first of all, I created data which is really messy. So this data is intentionally messy and this is important. In real life, you will rarely receive clean CSV files, and while handling messy data, you will understand how to handle such things. Okay. So here you can see extra spaces. Here there is an extra space between the employee name and different date formats. The formats of dates are with bar, something with dash, and another with invalid. Invalid word is not allowed because none is the word we use here. So maybe mixed capitalization in the first row itself. You can see David, Charlie, Bob, Alice. Everything is different, right? And you can also see hidden missing values. Like here, there is no values, it's a empty string. Okay. And inconsistent department names, yeah, it's really inconsistent. So also you can find this thing, the strings which shouldn't be in the numbers, numerical values. So, and also you can find 70,000 return in words. That's really messy and a wrong way of writing. Okay. So now we are going to deal with all this. So this is exactly the kind of data that breaks beginner level analysis. So our job as analyst is to fix all this before doing any business analysis. Okay, first of all, let's standardize the column names. So for that, I need to call the columns, right? So I'm calling df dot columns here equals, take a parenthesis, add a df dot columns. Followed by that, we can just follow it right like this in a straight line in a linear way, but I would like to write under this. Okay, so dot str dot strip and dot str dot lower dot str dot replace. What we are replacing here, we're replacing blank spaces with hyphen. Okay, here we can say it as dash. Okay, dot str dot replace it with opening parenthesis and quotes. Okay, then dot str, use closing parentheses with quotes. I mean the quotation mark. Okay, then we just call our tf dot columns. Okay, so this is first professional step, which is always need to do. Okay, so we need to standardize the data. So here we get some error. What is it? It's a attribute error. So while you go through this attribute error, we can see its replace word has no a. So we include a. We run it again. Then we will get the output. Okay, so we removed leading and trailing spaces, converted everything to lowercase, and replaced spaces with underscores. Okay, so we can see it here. The employee name was changed. It was once employee name with space and capital letters. Then we changed that, and also the opening and closing brackets also changed. Okay, department status, all these are changed. Okay, and the object is data type. Okay, still the object is a string. We didn't change that. Okay, so did you know why this is important? Clean column names prevent key errors. As you see, attribute error, which is happened because I wrote a replace without a, so we contained the attribute error. So if I worked with really messy data, what happened? We will get a lot of messy datas with errors. So if we didn't sort it and we just do the business analysis, we won't get a better result. So because of that, we first clean columns, names, and prevent key errors. They make our code easier to read, and also they prevent bugs in joins and to by. And then they will really help us while you follow consistent naming rules. So in real companies, this is often part of the data engineering standard. Okay. So our third step, that's handling missing values. So this is how our data is. Okay. And here I'm using tf dot replace with the parentheses, square bracket, hyphen, then comma, quotation mark, comma, the unknown in caps, and unknown in small letters. Okay, so I wrote both unknown because maybe people may use this type of keywords while having missing data. Okay, and I'm closing this, and I'm adding np.nan, comma, in place as true. Okay, then we just call our tf, also check everything is correct. Okay, then run. So one of the biggest beginner mistake is thinking that only nan means missing, but actually that's not the case. Nan means missing, but nan is not only the word. Okay, so in real dataset, missing values are often handled as dash, empty strings, or just word like unknown or n by a, all that. So if we don't convert this to real nan values, pandas will treat them as valid data, which breaks statistics, group by, and the analysis. Okay, so this step makes missing data explicit and visible. So you understand the importance of this data. Okay. Now we are moving to clean and normalize the test columns. Here we have a lot of test columns. First of all, df employee name. We write the employee name, hashtag name. Okay, I wrote the space with a dash. So we need to change it to the underscore. So I'm changing, not this actually, this one. Here I should change this to underscore. That's actually this one, and then run it again. Why didn't it changed? Because here I already given this and it is saved here. So you can delete all these, just copy and delete, or the best way is just add this to this place, and let's change this. Now it's changed. Okay, so we added the underscore. All this is now correct. We can run this again, and the name will be in underscore. Okay, and I'm really sorry for that. Okay, so here our column name is employee name, and df employee name. Also, we need to add .str, .strip, then .str, comma, I mean, and we are using .str, .title. Okay, so did you know why we use strip? Because strip is something vectorized, which is a method used in to cut off the spaces, also the tabs, new line, all that. The thing is, if we use just apple, if we just write apple, I mean, and space apple, here it is the same, but in pandas it is treated as different words. Okay, so if we use the str.strip method, it will be sorted out, and this will be cut off and counted as one. Okay, so this removes the white spaces from both ends, so it turns into the real data that we used in both cases. Okay, so it won't get treated as different things. Okay, that's how it works. I just say it for your knowledge. Okay, maybe you might be confused with the word strip because we use that twice. So now let's move to other name. That's our TF, which is department, and then we can add TF. Then we are adding department, then the .str.strip with parentheses .str dot uppercase is not needed, upper. Now we are moving to df status, and then just like the above, we just follow that pattern. We just df, then we give the column name as status, then we add the str.strip. It's a method, keep in mind. Okay, dot str dot upper, and now we are going to call df employee name, then comma department, then the status. Okay, so let's look. So test normalization is critical in analytics, and removing all extra spaces, standardizing the casing, make the names consistent. That's what we do here. We use title, which helped us to name the word only with starting letter as capital, and rather than that, the other two columns are wrote as in uppercase. Okay, because we use upper here. Okay, so here this part is super clear, I guess, because we followed the same pattern. We use df employee name, that's our column name. We give employee name str strip with title. We just need to know what should we use at the end. For first letter as capital, we use title. To get upper cases, we use upper. For lower case, we just use lower. That's all. Okay. So why we use this here? Because HR means here we found HR, IT, finance, unknown are not same as pandas. I mean, it didn't consider same in pandas. So if we don't normalize the test, group by and joins will create a wrong result. So why we just normalize it? Because as we said that the apple with a just a space in between the quotation can change the word itself. I mean, it will count it as different one. So we don't want such errors in our contest. Okay. So for that, we just normalize the test. And this is one of the most common real world data bugs. And now you know how to prevent it. Okay. So up to here, we learned about we imported pandas, we created a messy data set, then we corrected the column names, all this. And now we are going to work with robust date parsing. Okay. Dates are one of the most painful real world problems. Okay. So robust date parsing, it's maybe just new word, just a new word, but while we do, you will find it as super simple. Okay. We just join date, our column name equals pd dot to date. This is what time. Okay, this is what we used here, and we just give the column name, join dates, and we just separate with a comma, erase as course, and then we close the parentheses. Just call df join date. Okay. Here we didn't apply the name error. Here why we get a name error? Because it's a column and it need parentheses here. So dates are one of the most painful and hard thing. So different formats or typos and invalid strings can crash your code. So using error codes is a professional safety technique which will really help you. Instead of crashing, invalid dates become NAT, which we can later analyze or fix. Okay, so in the date format named as NAT because we give errors as codes. Okay, our sixth step, that is numeric cleaning with causation. Okay, for that we are using TF, salary, we use status, departments, and all that. Now we are moving to salary. We are using the salary with our symbol. Then here also we need to put that. Okay. Then we need to add dot as type. It was string, so str. Then dot str replace dot replace. We need to replace it with comma if there are spaces. Okay. And then we close it. Yeah, it's already closed, but we need to combine this in a single quotes. Okay. Then other thing is df. We are adding the salary with dollar sign, then equals PD dot to numeric and df salary dollar, then comma errors we give course in quotes, then we just call our df salary. Okay, hope it won't have many mistakes. Okay, so numeric columns often arrive as strings. We get it in a numeric value. As you see here, we get everything numeric because we added PD dot to numeric here. Last time, what did we use? We use to date time and also with error scores. Here we used to numeric with error scores. Okay, so uh, the numerical columns can contain spaces, commas, words, currencies, symbol, all that. And if there is space, it will be separated by a comma. If there is currency symbol or anything, it can be separated. Okay, so we first clean the strings, then force conversion to numeric, as we can do both, and it might turn it into an error. So we used different code lines to write it. Okay, and for any invalid value, it becomes nan, that is not a number. So this is how finance, revenue, and salary columns are cleaned in real analytical projects. Okay, so what all do we study here? We talk about S types, strings, which is replaced. Okay, we can move to our dates. There are some spaces with columns, or if there are just space, it can be exchanged. If there are something not set to this, it can be changed. Everything can be changed, and it can also consider errors if it not matching the format. And while we look at the NaN, we can understand some missing values are there. Last time for date we get NAT, and for this one we get NAN. Okay, now we need to move to our seventh step, that is smart missing value strategies. I know it's getting a bit longer, but definitely it will really help you while coding, because I'm just explaining everything for your knowledge. Okay, so we get all these things and we are moving to the smart missing value strategies. For that, I'm using salary and giving median equals df salary, the dollar sign, then dot, just dot and give median. That's what we need to give here. Then df salary, then dot filna salary median as comma in places true equals true. Okay, then here I use salary median, and then I started with df salary dot median, find it first. Then I add a df salary filna with salary median. So if there is some spaces, it will be filled. Okay, we can just df, can understand that. So here we find some errors because we didn't add a box, and this was at the end. So the attribute error was string object has no attribute filna, but actually there is, but our bracket was missing. Okay, so here you can find all the missing values of salary column are just filled now. Okay, before that we can go through this. There are some missing values, there are some numerical values, string values, all this. But now while you look through that, you can find every value is just filled because we added the median, and it will take the median of the salary and replace it with, that is fill the word where there are none values. Okay, so that's how it works. And what happened if we use df department, then dot filna, and we are using unassigned, and then increases true. Sometimes I forget is true, and then we are giving df status with the dot filter, then we are giving unknown, Okay, and we are providing the unknown, comma, then in places we need to give comma and in place equals true. Okay, so just TF then. Now what we are expecting? Yeah, we get many places filled while the status is now unknown, inactive, active. So before that it was none, not a number. Now it's changed to unknown because we provided the value unknown. When it comes to the department, it was unassigned. So we need to assign it later or soon. Okay. So professional analysts do not blindly drop rows. Dropping data can destroy sample size and bias results. Instead, for numeric values, we often use median. For categorical values, we use meaningful placeholders, all this. Okay, this keeps data usable while preserving business meanings. Okay, now our eighth step, that is data optimization. Okay, we are moving to data optimization. For the STF, I'm giving department itself, then equals I'm giving TF department, then dot S type with category, then we are providing TF status dot S type as category. Okay, so I should also provide TF status here and I use a equal sign. Okay, so there's no errors, like we can get TF info. Hopefully we don't have any errors. Okay, so converting repeater test fields to category is a powerful optimization, and it reduces memory usage, speed up group by, also improve performance on large datasets. This becomes very important when working with millions of rows. Okay, that's why we changed and we reduced memory usage just using the word category as S type. So by converting this repeater test fields to category is just amazing code, and it helps us to speed our group by much more easily. Okay, so we get all this, and now we are going to data quality. For that, I'm using df dot is now and dot sum, also invalid salary equals df bracket df salary, and then is less than or equal to less than 0, just called invalid salary, and we just provide a bracket here, add invalid salary. Okay, so professional never blindly trust clean data, so we need to know how the data is. So we always validate, we check remaining values, impossible business values, or logical inconsistencies. So for that we used invalid values if the salary is less than 0 or not, and we tried this and we don't have such values. So this step protect your analysis and your credibility, so keep it in your mind. The final clean, so we are going to clean the data set for final. So df, we need to clean it. Clean equals df dot copy, then df dot clean. I'm sorry, df space clean. So this is now an analysis ready dataset. We can confidently use this for group analysis, time trends, and joins, feature engineering, business reporting, all this. This is what professional data preparation look like. And yeah, that's all for today. And it's a bit longer video. And most cases I used to speed my voice. This case I will reduce the speed of this. Okay. And in Pandas Advanced Part 1, you learned how real analysts clean and normalize messy data in real world. This is not glamorous, but it is one of the most valuable skills in data analytics. If you master this, you will prevent bugs, improve analysis quantity, build trust in your results, work faster and more confidently. And in next part, we will move from cleaning to applying business logic, advanced filtering, where real insights start to appear. This is where Pandas become a real business tool, not just a library. Okay? Thanks for watching. Keep watching. I found many of the revisitors here. So I'm really happy to see you here because you have a talent, you have a mindset to come and learn more and more. That's really amazing. I really congratulate and compliment that skill because it's a skill many of them lack. Okay, so keep learning, keep moving. You're going to be in a high position soon. Have a great day. Bye, buddies.